Bonjour, Kinamagi Nene Ireland Dijnikas, and welcome to today's math enrichment lesson. Today's lesson, Imperial and Metric Units of Weight. All right, let's begin with quickly a share of our whiteboard. Some terms that we have used we'll be using today. We have milli, which means 1,000th. We have centi, 100th. We have kilo, which equals 1,000. You'll also see us using terms like pounds, ounces, tons. And I'm going to utilize a couple resources today in this episode, both of which are from Khan Academy. They're a really good resource that I encourage you to use when you study for any kind of assessment or any skill that you're struggling with. So the first one is the metric system, units of weight.
Let's think about the units typically used in the metric system to measure an object's weight. And I'm putting the weight in quotation marks right over here because the units I'm going to talk about are actually, if we wanted to be technical, they're units of mass. And as we'll see later on in our scientific careers, that weight and mass are not the same thing. They are related. Mass you could view as how much stuff there is. How much substance does an object have? How hard is it to change the velocity of an object? While weight is, what's the force that gravity is pulling down on that object? Now, in everyday life, if we're just on the same planet or the same part of the planet, if something has more mass, it's going to have more weight, and if something has more weight, it's going to have more mass. And that's why in everyday language, these words are often interchanged. Later on, we'll see that these mean different things. For the sake of this video, because we're really just getting ourselves warmed up with some of these units, I will use these interchangeably. I'll use them in kind of the everyday language sense, not in the technical physics sense of the word. So in the metric system, when people talk about measuring relatively light things, they will often use the gram. And to get a sense of things that weigh a gram, one example is a paperclip. Your average size paperclip would weigh about a gram. A stick of chewing gum, not even the whole pack of chewing gum, just a stick of chewing gum would weigh about a gram. A dollar bill would weigh about a gram. So this really isn't a lot of weight. Now, if you wanted to measure things more on, I would say, a human scale, you could then increase by a factor of 1,000 and go to the kilogram. And as the unit implies, as the prefix implies, I should say, kilo, 1,000. This means 1,000 grams. And if you want to think about how much that represents, well, many people will measure their weight in terms of kilograms. So I, for example, weigh about 70 kilograms. And I'm 5'9", and I'm of about average build, and I weigh about 70 kilograms. If you want to imagine what a kilogram is like, imagine taking a liter of fluid. Or a liter of water. So if you took a liter of water, and a liter, you could imagine as a 10 centimeter deep cube, 10 centimeters wide, and 10 centimeters high. If you fill this up with water, the weight of that thing is going to be 1 kilogram. And things, I know you're not used to walking around with 1 liter cubes of water. Another way of thinking about it, if you go to the supermarket and you were to buy a 2 liter of soda, and sometimes you can buy 2 liters of other things as well, water, whatever. If you buy a 2 liter of soda is going to weigh, well, actually 2 liters of water in particular is going to weigh. Soda has other things in it, so you can't be as precise with the weight. But 2 liters of water, I should say, are going to weigh exactly 2 kilograms. If we don't, and we're just talking about the water itself. We're not talking about the container. But if you want to get a rough sense for how much weight that is, that's going to be 2 kilograms. So if you're measuring, human scale size things, reasonable size quantities of fluid objects around this scale, kilogram makes a lot more sense. If you measure these very light things, you're talking about a gram. If you want to get really precise, and this might be more in things of if you're doing, a drug dosage and you need to be very, very, very precise, then you will sometimes see people go to the milligram. But you can imagine a milligram is 1,000th of a gram. And so 1,000th the weight of a dollar bill or 1,000th the weight of a paperclip, this is very, 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 very small. So this usually doesn't come into play in our everyday life.
All right, so we have now the metric, and now let's look at our US units, the imperial.
Let's talk a little bit about the U.S. customary units of weight. So the one that's most typically used is the pound, especially for things at kind of a human scale. And to understand what a pound is, most playing balls are roughly about a pound. So for example, a soccer ball, my best attempt to draw a soccer ball. So let's say that this is a soccer ball right over here, and then of course it has some type of pattern on it. So you could imagine a soccer ball is about a pound, so it's roughly 1 pound, and a pound will often be shorthanded with this LB period right over here, so it's about a pound. A football, an American football, is also a little under a pound, but we could say it is about a pound, just so we get a sense of what a pound actually represents. Now, if you want to go to scales smaller than a pound, you would think about using the ounce. And the relation between the ounce and the pound when we're thinking about weight is that 1 pound, let me write this, 1 pound is equal to 16 ounces. Or another way of thinking about it is that a 1 ounce is equal to 1/16th of a pound. And if you want to visualize things that weigh about an ounce, you could imagine a small box of matches weigh about an ounce. So a small box of matches might weigh about an ounce. Maybe a small AA battery would weigh about an ounce. But that gives you a sense of it. So if you were to take 16 of these together, they would be about the weight of a soccer ball. 16 of these things together, they would be about the weight of a soccer ball or a football. Now, if we want to think about weights that are larger than a pound, then we would go to the ton. And a ton is equal to, 1 ton is equal to 2,000 pounds. And you have to be a little bit careful with the ton. We're talking about the U.S. customary units, and this is where we're talking about 2,000 pounds. But when we're talking on a more international level, this is sometimes called the short ton. There's also a long ton. There's also the metric ton. But here we're talking about U.S. customary units, which is the short ton. So 1 ton is 2,000 pounds. And to get a sense of something that weighs 2,000 pounds, or to get a sense of what 2,000 pounds is like, or what might be measured in tons, a car is a good example. Your average mid-size sedan would weigh about a little under to a little over 2 tons. So a little under to a little over 4,000 pounds. If we're talking about a small van or minivans or vans or trucks, it's going to be larger than 2 tons. And if you think about smaller cars, you're thinking it's going to be probably around 3,000 pounds. It's going to be less than 2 tons. So a car is going to be approximately 2 tons. So hopefully that gives you a sense of what units you would use in the U.S. customary system for different scales of weights.
And we would measure those if we're going pounds to tons, obviously 2,000 pounds in a ton, and there's 16 ounces in a pound. So at this point, you should return to the Google Classroom to complete the assignment. If you have any questions, please reach out. Have a minute, get you got. Meanwhile, I'm a P.